So what is a distributed system? Why would you want to build one? And what are the pros and cons? A big issue with learning this stuff is that there's a lot of jargon and buzzwords which can be really confusing. So one of my main goals here is to simplify this stuff and clean up some of that confusion. Another big thing before we even go into the nuts and bolts of distributed systems is that really it's important to emphasize that you should always keep things as simple as possible. MIT's own professor who teaches their course on distributed systems says that whenever possible you should avoid using them and just avoid the pain involved with managing them. Google and Facebook and Amazon, all these big tech companies you've heard about, they didn't make their distributed systems for fun. They did it because they had no other choice available to reach the scale they needed to. If they had their choice, they'd have some sort of magical computer. Their applications could run on a single computer that magically handles all that traffic, but in the real world we don't have that option, and that's when you turn to these more complicated distributed systems. A lot of engineers lose sight of that, and they either just want to improve their resume or make something cool, and they end up making something that's very complicated and doesn't work properly. So if you learn nothing else from this, I'd say that it's to always keep your design for your applications as simple as possible, and then only change things once that's required. So with all that out of the way, what exactly is a distributed system? Basically, it's a group of computers working together, and the goal is that all that complexity should be hidden completely from the user. So to the user, it's like they're just interacting with a single computer. Behind the scenes, when you think about something like Google, Amazon, Facebook, they have multiple data centers with hundreds of thousands of different servers, but to the user, all that complexity is abstracted away. They have no clue that all that is happening behind the scenes, and that's what this diagram shows. To the user, they just have this magical distributed system. It could be Facebook, whatever. They make a request from their cell phone or their laptop. Behind the scenes, all these different services are working together, and they return a response. So all that stuff is hidden away. It's like a magical little box, basically. Obviously, this isn't an easy task, and that's why software engineers make so much money at these big companies. Billions of dollars have been invested in research and development to figure this stuff out, and that's some of the issues that arise with these systems are what we're going to cover coming up next. So that brings us into the so-called fallacies of distributed systems. So operating at a huge scale requires an entirely new way of thinking, and most programmers, when they come into these big companies, they haven't been exposed to this type of stuff. So the fallacies are these kind of wrong assumptions that most programmers have the first time they're exposed to these systems. They're real issues, but they're also kind of an inside joke. So the first one would be that the network is reliable. When you're running your small application on a single machine, you don't have to worry about network issues that much. When you're doing a distributed system, you have thousands of machines talking to each other, and the network will often break at some point. Latency, you're going to have latency between those machines as they're talking. Bandwidth, when you're moving data around all those different servers, that becomes an issue. The topology of your network, that's going to change as servers go down and other ones get brought up. That's going to be something you have to compensate for. Security within your network, the fact that only one administrator, so there's going to be multiple people working on the system and potentially changing it, and that the cost of moving data around is zero. So these are some of the main things that as a programmer you're not really thinking about when you're building small scale stuff, but that it becomes a big issue when you're working with distributed systems. Some common characteristics of distributed system are, first off, that they don't have a shared clock. So all those individual servers are running on their own time, and this leads to an issue called clock drift, which is where the timers on each computer get out of sync, which can lead to big issues with ordering of events and stuff like that. You could theoretically, if you don't handle this problem, get an error where it seems like there's negative latency. It's like time travel, where because one clock is off on a computer and it sends a request to another, it results in basically big issues related to the timestamp on those requests. So Google did a study on it and said that if you only synchronize your servers once a day, you can get a 17-second drift in either direction, which could obviously cause a huge issue. If you have something like a stock exchange or some sort of auction site like eBay, and somebody on either side is off 17 seconds and they can basically game the system, that's going to be a big problem. So Google, to handle this problem, they actually use a combination of GPS receivers and an atomic clock, and they call it true time. So they have a pretty complicated system to take care of that issue. No shared memory is pretty obvious. Each node or server in your system is going to have its own RAM, its own storage. So if it needs data from somewhere else, it's going to have to request that from the part of the system that does have it. Resource sharing goes in line with that, which is that anything in your distributed system should be able to be shared between nodes on the system. So that could be hardware, software, or data. And then finally, you have concurrency and consistency. So the different parts of the system are going to be working together and working at the same time, and you want to make sure that there's consistency between how that all works. Since information needs to be passed around our distributed system, they obviously need some way to communicate. So there's a lot of different strategies to do this, but at the most basic level, it requires some sort of uniform format or protocol so that the different parts can understand what the others are saying when they pass messages back and forth. You can kind of think about it like a just general human language. Like if somebody's speaking Spanish and somebody else is speaking English, you're not going to be able to talk to each other. And that's similar to how it is with computers. These communications, when you're doing them at scale, there's a lot of things that can go wrong that you might not think about, and you need to be able to handle those. So in one case, you have a client can't find the server. It sends a request, but the server is not responding. So you have to have some way so that the client can find another server that can serve it. Another one is that you do find that server, you get the request across, but midway through while it's processing, that server breaks down, and now you have to figure out a way to resend that request. The alternative is that the server has a response, but the network fails, so it tries to send it back to the client, but the network fails halfway through, and now technically your server thinks it's done its job, but the client still doesn't have the response. And finally, another way that the communication can break down is that the client itself breaks halfway through the response. The server has nothing to send it back to. So you have to have some way to, maybe in that case, the server stores that response until it detects the client again, and then it can send it out. But a lot of stuff that with smaller scale stuff you don't have to worry about, but when you're dealing with distributed systems, it becomes a big issue. So all this stuff sounds pretty awful. The benefits are why people deal with all these issues. So first off, it's more reliable. If you're running on a single machine, if that thing goes down, your whole system goes down. Next, you have scalability, which is kind of an aspect of that as well, which is that because your whole system is designed to work on multiple machines, it's very easy to just add a few more machines or nodes, whatever terminology you want to use. So if you are gradually getting more traffic, it's really easy to just add some more nodes and scale up. You also get the benefit of lower latency, which means that because, once again, you're distributed, you can have your application running out of multiple data centers all around the world, and that means you're closer to the user, so it's reduced latency, increased performance, and finally, it's more cost effective. At some point, you just can't buy a larger single machine, and with a distributed system, you can buy a bunch of commodity servers that are very cheap. You can buy them in bulk, and then you can just run your software off those. That's it for this video. I really just wanted to go over some of the terminology and basics of distributed systems. Be sure, if you're interested in more of this stuff, to hit subscribe, and also check out my previous videos in this playlist on system design so that you can go more in depth on what actually makes up a distributed system. If this video helped you out, make sure to hit like, and also if you have any questions or topics you want me to cover in future videos, be sure to leave a comment.